All right, in this video we're going to look at how to check if a file exists. Last time we learned we can use the OS stat to check for stats, check for if it exists or not. So this OS stat returns a file object and error. So if it doesn't exist, it should return an error. So basically, if it returns nil, then file exists, right? And we can use this helper function from OS is not exist and error and pass the error object thingy, and this helper function tells us whether, so it guarantees that it's the file and it doesn't exist. All right, let's use that. Okay, OS file stats, OS stat, and use hello txt. This does exist in my directory. So this returns a file object and error. So if error nil, then we know the file exists. File exists. Else OS is not exist or something. What is the method? It's not exist. Is not exist, and give it the error. What is written? If it doesn't exist, it should return true, right? If it returns true, then we print file doesn't exist. File does not exist. File exists. Okay, that file does exist. This doesn't exist. File does not exist. Also, what is the error object? What is it? File does not exist. Get file attributes x. Hello to txt. The system cannot find the file specified. So the type of error we get is this, like get file attribute x. Exception, I believe. So is not exist returns a boolean indicating whether its argument is known to report that a file or directory does not exist. It is satisfied by error not exist as well as some syscall errors. This function predates errors is. It only supports errors returned by the OS package. New code should use errors is. So yeah, fs file system error not. All right, let's just change it to that. I believe OS is error. What was that? I think it started from is. Okay, no. OS. Okay, we are supposed to use errors is. Errors is. Text error and what the hell? Okay, fs error not exist. Fs error not exist. Okay, this is really hard to remember. Okay, file does not exist. The system cannot find the file specified. Anyway, like why? Generic file system errors. Errors returned by file system can be tested against these errors using RCEs. Okay, so this is sort of like a broad type of errors, broad category of errors that contains file errors, right? File errors, basically this is a container for file errors, and we can only use it to we can only check it using errors.is. So why does it need this? Is function takes error and target. Is reports whether any error in errors tree matches target. The target must be comparable. The tree consists of error itself, followed by errors obtained by repeatedly calling its unwrap error or unwrap error method. When error wraps multiple errors, it examines error followed by a depth-first traversal of its children. An error is considered to match a target if it's equal to that target, or if it implements a method is error bool such that is target returns true. An error type might provide an is method, so it can be treated as equal to an existing error. For example, if my error defines func my error as this method is target, as target is a type of error, and returns boolean, returns target is equal to fs error exist, then is my error fs error exist returns true. See syscall error no dot is for an example in the standard library, and is method should only shallowly compare error and the target and not call unwrap on either. So we just need to provide the error object. Error object seems to contain a ton of errors in it, and this takes the error object and checks if this error object contains error not exist type of error. So that's pretty much it. That's how you check whether a file exists. And also we could check if if it's a file or a directory, right? This works on a directory. So let's see. Let me create a directory. Currently I only have file utils. Let's see if it works on it. File utils. Let's check if it exists. If it exists, then the error should be not nil, right? If error is nil, then we know it exists. Println it exists. Whatever it is, it exists. Okay, my bad. Okay, whatever it is, it exists, right? How do we know it's a file or a directory? Okay, so we stat returns a file info object, right? We can check the file info object. Okay, let's just print the file info object, and yeah, let's see if it exists, and print. Okay, let's put in a new line and then print info. So this is like, what is this? How do we print? How do I print the file info? How do I print the file info? It just returns some numbers, bruh. Right, file info, which is kind of ugly. Cryptic goblin, useful stuff. Example. Pretty formatted. Why? File info implementing internally, so go print something like, that's not wrong, just low level summary. If you only want to know, okay, do I know, can I know, like, how do I know, like, wait a minute. Okay, we need to check the documentation for the methods available on it. Let's go to OS file info. Bruh, moment. Okay, dude. Okay, file info. File. Okay, not file info. File info. Okay. Jesus Christ, what is this, man? File info describes a file and is returned by stat and ls stat. Go to file info. I mean, like, what is this? If we go to the type definition, file info, it's just a type. File info is a type, and what am I supposed to do with this, bro? Just returns all the types in the OS type. How the hell am I supposed to know its methods? You don't magically know. You inspect the type docs editor autocomplete. VS Code IntelliSense the normal way and pass. The normal way, bro. That's what most do instead memorizing random goblin methods. Look at function return type. Docs say, well, now what the hell is file info? Look it up. Go look it up. Control click. Control click. Doesn't do anything, bro. Look it up. Look it up. Go docs show. Boom. Terminal docs. Go has built-in docs. Okay, let's do that. Go doc OS file info. File info describes a file is real to nobody memorizes methods. So the most obvious way would be to use like this dot syntax, and it only has like couple of methods, bro, like is director, maritime, mode, size, name, size, sys. These are the only freaking methods on this. Although it would be nice if I could find it in the docs, but I cannot seem to find it, bro. Um, File info package. Anyway, I cannot find information on it. Anyway, so we now know this file info object can tell if it's a directory or not. It would be nice if I can use the ternary operator like this. I have like some condition and I check if it's true. I want to return something 1. If it's false, I want to return something 2. Does Go have this? Does Go have ternary operator? Go should not does not use normal if. Normal if. Okay. Can I put the if here? If info dot is directory what do I do instead of yo? So basically we want to do something like this. fmt print ln, it's a directory. Although looks like we cannot put this in the print ln parameter is a parameter. Taking a bit of, okay, it exists, it's a directory, and let's do it hello txt. Okay, it's not a directory, but it exists. So that's how you check whether a file exists in Go. Working with JSON, this is your create Go struct for JSON. To represent JSON in Go, you make a struct with fields plus JSON tags. Example JSON. So if you did not know a JSON is basically a stringified JavaScript object. So for example, JavaScript objects, like let object this is how you create object in JavaScript. It takes key values. So let's use name and nameless. Oh, nameless, age 24. So we got an object, right? To turn this into a JSON, we just need to call JSON stringify. So this is basically strings. Normally you just pass the JSON around using HTTP protocol. Anything that can, so other programming languages just need to parse the JSON and convert to their native objects. Converting JSON back to JavaScript object is pretty easy. So let me save it into an object, to variable, say JSON string, and then to convert it back to JavaScript object, use JSON parse JSON string. Boom. Now we can do any operation on the object. All right, so this is the JSON key value pairs. You can wrap the key using double quotation mark or something. So this is a string, this is integer, this is boolean. Okay, now go struct. We use the type, and type followed by the name, variable name, I think, and struct. So the type, name, string, JSON, JSON name, JSON age is student. Breakdown, field name. Go field names must be capitalized if JSON package should access them. Wrong, name string JSON ignores this. Right. JSON tag means JSON key name maps to Go field name. Decode JSON struct. Package main. Okay, import encoding JSON. Encoding slash JSON. What is this format? This is not okay, this seems to be a package. This seems to be a folder, and inside of that folder we have another folder, JSON. That's got to be it. So now that we have created the struct, we can take the string. They are using a backtick for this instead of the single quote, means preserve the new line or something, I don't know. So we can write strings like in a new line. That's just a speculation, I don't know if it's true. So we create a slice. What is this? We know for a fact this is a slice instead of an array type. So we store it in the data, and we are creating a variable that's a type of person, and we use JSON unmarshal and pass the data, the JSON string, to the address, of, so this is This is how we write to the address to basically where kind of confusing, to be honest. So we are basically writing like assigning value to the person, basically, I think. So if we get error, we handle it, and after this we should be able to access those values. Okay, so first let's create let's try to extract the JSON and convert it into Go object. First we need to build the struct. So the JSON object I am building, let's just call this app.js, and also let me grab the whole code. So this is what we are trying to build, right? All right, now we have JSON string basically. So I'm gonna keep this here. First, we need to build the struct type person struct, and field names starts with capital letters, name, and it's a string and some JSON thingy. So this field maps to the JSON's field name. So we are just mapping the fields basically. We need to use the JSON colon and the field name in the JSON string. So this map, like, so this is a key and this is a value, right? And looks for this key, gets this and assigns that value to this field. So age is an integer, so JSON age. So we built the struct. Now we need to import the JSON encoding thingy. We need to import encoding JSON. First, let's just store the string. Okay, my question is, why are we storing it in a byte instead of string? So date. So this byte, we saw last time that we can just, this converts the string to bytes basically. If we use this like this, instead if we use this bracket syntax, we need to manually pass each bytes, basically it just accepts bytes. This converts the string to bytes. Okay, my question is, why are we passing bytes instead of string? Why bytes instead of strings? Because Ghost JSON package works with raw bytes, not strings, since JSON is fundamentally text bytes in UTF-8. That means create a string literal, convert it into bytes. Why does JSON unmarshal want bytes? Signature unmarshal takes byte and as a v any and returns error, not string, because JSON usually comes from files, read file which returns byte. HTTP, we can use the read all response body returns byte. So although in the previous video I said this is an old method, we are not supposed to use it, but it's very useful when we want to parse HTTP response. This only works on path, this text streams. Okay, there was a bit of a sidetrack. Network stream buffer. So everything returns a slice of byte. So that's why they designed around raw incoming bytes. So we need to convert the string into bytes, because that's just how Go works, man. Like this is an exception. Usually you get bytes everywhere. So first import the JSON, encoding JSON. This JSON unmarshal takes data. Okay, what is it return? It returns an error. It only returns an error. What do we do? Okay, this returns an error and also accepts where do you want to put the data back or something. So let's just person. So this is when I use it like this, it's just empty. We're just referencing the type. But when we do this, it kind of reference I don't know, dude, like what the hell. So we need to create an object. Basically we need to have a variable, let's say person, that has this. So this just initializes empty person, and we person. So what's the difference between using like this and this? Let's ask ChatGPT versus super important. Is correct, is wrong, because unmarshal needs a pointer so it can modify your variable. Function signature looks give me any value, but internally it expects a pointer to something writable. So you passed person, that means here's a copy of my struct. Go hands JSON a package a copy. Cool, but I can modify your original variable. Person means here's the memory. So yeah, this is a memory address of person. Now just package can go to this address, fill name field. What if I used this goofy syntax? So it only makes sense if person is already a pointer, and even then it's wrong here. Normal struct then is illegal because person is not a pointer. Go basically says there's nothing to dereference. So this is something like a dereference. Okay, so when we initialize pointer, we use this syntax, and if we pass this like to function parameter or something, it dereferences it or something. Pointers are confusing. Anyway, so what we are supposed to do, we just pass the address. So if we use this syntax, we are passing address, and it takes the address and fills the value basically. Now we can go ahead and println print user. I mean person. All right, we got the name and age. Cool. Okay, we decoded JSON to Go objects. Now let's encode our Go objects, basically struct, to JSON string. So we are essentially taking Go objects and converting into JSON string. Let's do that. Var, let's say person a name, let's say, and age 4. Okay, now we can use JSON Marshall and pass the data basically, and this returns bytes. So data and error, fmt println data. Okay, this Marshall returns a slice of byte, so we just need to convert that byte to string. Okay. Okay, now we will use the create. We'll save it into our file. So let's use os write file. Takes a path and data and permission. Okay, so the name test JSON and the data and permission. Let's use this. What is it? Returns error. Okay, I'm not gonna bother with the error. fmt imported and not used. Okay, cool. So essentially we just created a JSON file. Now let's read it. So we need the struct object. So we're gonna read this JSON. So So if you want to read a JSON, you just need to know the field values, types, and shit. That way you can create the struct and create a Go object. Okay. So we can use the open file as open and takes string test JSON and returns a file and error. File error. What method do we got? Okay, let's just close it after opening it. We got a file, but how do we read it? So we need to go back to our notes and check how to read it. How to create, how to wrapper, read. Cool. We don't have that. Read files using read file. Okay. Instead of opening it, we can use read file. Cool. So this, what is the return? Okay, returns bytes and error. So data. And then we can use JSON unmarshal text data and we need a empty object. So person. So let me just type in cat and person. Doesn't work. What is going on here, dude? How do I initialize it? Oh, wait a minute. Var person var cat person. Okay. Oh, we did not use it. Okay, that's just give it the address and fmt print ln. This doesn't. Okay, now we just read. We convert. This is a struct. So how do we read the struct? We just put the struct in and cool. So we essentially read JSON saved in our file system and converted into Go object in memory. Now we can do some stuff to the JSON on our Go program if we wanted to. Great. We learned how to create JSON and save it to file system and read back JSON from file system in the program, basically. All right, let's look into nested JSON. So we got a field and a value, key value, field value, whatever you want to call it. So essentially this contains another object inside another object, basically. So that's what we call, that's why we call it, it's nested. So let's just get the string. So we need, how do we parse this? So for this field, for this nested object, we need to create another struct, basically. So type address struct and cd string. Use the backtick, not single quote or something, JSON. cd pin string JSON pin. Okay, we got name, age, and address. How do we put the address? So name, address. Okay, we're not using age, so I'm gonna remove that. Address. What type of? It's a struct. Okay, it's a address. What the hell did I just write, bro? Although it works here, like it's supposed to work. Undefined address. Okay. See if it works. Match address. Do I need to put this in at the top or something? Struct field tag JSON address. Okay. Cool. So we can now parse nested object. Okay, let's quickly parse it. JSON and Marshall. Okay, we need to pass the string. So data. Say JSON string. Pass the JSON string, and we need an empty object var person. And then we can go ahead, print it. Okay, we got one error. Okay, I was not using that package. Cool. So although we were able to, it's not like putting everything, right? It's not displaying all the fields. Go isn't printing all the nested JSON fields. Usually this time because one of three things. This is not printing, it's your struct type mismatch. That's a pin. But your struct says pin. String in quotes. Failing silently because you ignore the error. Pin. Use correct type. So we got an error or something. What is going on? Oh, that is a number that expects a string. But your struct say pin is a string that expects string in quotes. This is a number, so that's why it's failing. Cool. Now it works. So this is how you would, try to read a nested JSON string. Create struct for every nested object, basically. I think this is pretty verbose. Can we shorten it? Go can feel pretty ceremony heavy. Explains way better, few shorter patterns. Inline declaration, same thing, just shorter. Checker in one inline. This is super pointer allocation. Instead of new returns pointer already. So no utility function. So there's no like elegant way of avoiding this. So you just need the address, bro, like every time. So how would I do this if I was in JavaScript, bro, basically? Let's just go ahead and write it, bro. Let's just get basically do like if you have a string, just like I showed you at the beginning, you don't need to pass anything. You just pass the string to JSON, pass some bullshit string, and then save it to a variable. That's it. And that JavaScript developers call it a day by doing this. But in Go, create an empty person instance, pass the address. Cool. So we saw how to handle nested, and now let's look at array. So we got an array. How do we do it? Okay, so this is a string of array, but in JavaScript there is nothing stopping you from putting other types in an array, right? Let's say let my array is some string, some number, some object, there's literally nothing stopping me from putting different data types in the array. We hope and pray the developers that created the JSON response as single single type contained in the array. All right, let's just let's look at it, how to do it. So we got an array, and first we create the field. So it's a slice of strings, so it's an array of strings. I'm just gonna say array of string instead of saying slice of strings from now on. It's just much easier. So it's just an array of string. So this maps to skills field. And okay, let's do it. Let's parse a JSON string that contains an array. Okay, the reason I'm doing it like this because I want a JSON string. I don't want to manually write it. So JSON string has this weird you know rules where you have to surround the field, the key value, the field value or whatever with a double quote, strings with double quote, surround everything with double quotes or something. All right. So we got a field name skills. Skills, it's an array of string JSON skills. So we got an mtr instance. Cool. JSON string. All right. Let's create that JSON string. Cool. Now it should parse it. Fine, just fine. Cool. Great. We learned how to parse a JSON string that contains array. Okay, now let's learn how to parse optional field. Some JSON might be missing some field. So we can say omit empty. Okay, this, like for example, if the JSON doesn't contain skills, we can say omit empty. The IDE does not give any hints like what other things this accepts. You just need to know, bro. So I'm gonna leave this part out and everything just work fine. But this creates an empty object. Why? Creates an empty slice if it's missing. Not exactly. This creates a nil slice, not an empty slice. Your JSON has no skills. You get skills, not empty. Why looks confused? You'll see and think an empty slice, but Go prints nil slice and empty slice the same sometimes. Nil slice, length 0, compare. Missing field, nil slice. Missing field, nil slice. Result, skills nil, empty array. In JSON, real empty slice. Let's just check if it's a nil. fmt print ln person skills. Is this equal to nil? If it's equal to nil, then we know it's an empty slice. So it's true. But if our JSON has empty skills, then it should not be a nil slice. skills. Okay, should say false. Cool, great. Then we can, if you want to make sure skills contains elements, we can check length and try to process it that way. Generate struct automatically. So we can go to this website, JSON to go struct. Bookmark this website and paste JSON, and it will automatically convert your JSON string to structs or something. Okay, let's paste this. How to generate a struct name skill. Cool. Let me try to find a really long JSON. Anyway, I asked ChatGPT to give me a complex JSON string, and now we're gonna paste it here, dude. So it inlined everything. Whoa, like. Okay, so basically you use a website to generate this struct. Cool. I guess that's pretty much it. Shit. Okay, let's try to create library functions. Let's call parse JSON. This takes JSON string, which is let's just say bytes, and JSON struct are we spelling it correctly? Which is a type of struct. And what's this supposed to return? This does not return anything, dude. So we probably need to use generics or something. How do I create this function? Should be byte struct, not a valid parameter type like that. JSON parsing needs a pointer to something writable. This is normal utility using any JSON data target error return JSON and Marshall target. Use it. JSON string error if error not error print error person. Interface basically accept any type. Y pointer is required. Okay, JSON. Okay, if you want a typed return, go generics, parse JSON. Okay, so this is a generic type T any JSON data byte returns a type. returns generic whatever input. So result, we create a result with um cool. Okay. Parse JSON, give it the type JSON string. All right, we're gonna use the generics version. Okay. To use the generics, we need to use after the function name, I think, right? After the function name, we use the generics, some variable name, and we could use constraint or something after that. Okay, JSON string bytes doesn't return, and after this we return t and error. So we take the type t and initialize it with t, and we need to call JSON on Marshall. Need to provide JSON string and the pointer and address to the result, and after this we return result nil. Does this return error? Right, so if it returns error, we handle the error not nil, return. So the result, how do we return empty result? Do we pass it like this? Nope. So empty, we just return an empty result basically. We could also do it like this. We don't even need to explicitly check for errors. So this is a modern approach. Use generics and return result. Okay, I'll keep that, and it's called parse JSON. Takes we need to pass actual type for the generic person. If you look at it, we need to pass a JSON string, and that's a type of byte. And what's the error? Missing before new line in argument. Byte. All right, so we got a error before in the argument list. So what is going on here, dude? So if we use it like this, um, so it's some sort of like multi-line thingy, then you have to use a comma for whatever reason. So now this returns a person. Print ln person. Cool. Okay, now it works. Let's move this. Okay, so some naming mistakes. We don't want to use the string because it's not really a string. So it's just a language semantic problem. It doesn't mean what it says, basically. So now kind of means the same thing. So the byte, every time I use byte, I want to use the data. Right. We just extract and put it in our ever growing library of functions. Import the JSON. Quick fix, add import encoding JSON. Cool. And now we can go ahead and import that package. Learning Go file utils. File utils. Boom, works. So this has become a reusable function. All it needs is data, and then the struct that kind of gives Unmarshal some needed information on how to convert the JSON back to Go objects or something. All right, let's take count. Create Go struct for JSON. Okay, we did that. We did do that. Convert Go object to JSON. Cool. We also did that. Write JSON to file. We did that. Write JSON to file. What did we use? What did we use to write? I mean, it could be write file or create or something. Read file. Okay, read JSON file. We used os.read file. Parse JSON back into Go struct. Cool. Pretty print JSON. How do we do that, bro? Handle option missing field. Okay, we did that. We use omit field when we created here omit empty. Now pretty print JSON. How do we do that? Pretty print JSON in Go. Ah, Go is built in pretty JSON with JSON Marshall indent. So JSON Marshall indent parameters value what to convert percent map slice struct prefix stuff added at the beginning of each line, usually empty. Indent how much spacing, common, two spaces, RT, a tab, preprint struct, preprint struct. Cool. So we pass the object, the what to print, put at the beginning, how much space, output, preprint already existing JSON string. If you have a ugly minified JSON, um, so this is a JSON byte example. Unmarshal, okay, we have unmarshal converted into JSON object, I mean Go object, put it here and print it. Pretty JSON, pretty whatever, why not output ugly goblin output. Okay, first, what is this? Map key, this takes key value thingy. How does the map work, bro? Pretty print JSON. How does this work? How does the map here work? Create a map where keys are string, values can be anything. Break it down. Where it's like map of key, string, any, whatever. Works because key is string, values that, okay. It's the actual content. Same idea as a JSON object. Go. So we have a key value pairs, map, but when we convert it, it's gonna be like a struct. So we can't really use it. Like, why would I manually type key and a value and nothing, a JSON, Marshall indent or whatever needs an object anyway, and unmarshal converts back to an object. So I'm gonna use the object returned by the unmarshal. So usually we end up with a struct, right? So let's just use that and marshal use a marshal indent on that struct. So if we learn to do that, we should be able to okay. We have struct object. This is JSON Marshall like, why is this auto in the auto thingy not work? JSON Marshall indent takes object and what to put at the beginning and how much space. So what is it return? Returns a byte. So let's just use data and something like this, and fmt println and convert the data to string data. And boom, we should get a pretty print. I guess that's pretty much it. Let's try to convert a like massive JSON to pretty printing. That's going to be really cool and exhausting. In our chat, I asked it to give me a really long JSON string. So let's use that here. I have a really long JSON string. Now convert this to struct. Okay, something is wrong here. Right now we have the test JSON. All right, we need the type. We grab it from here, copy the clipboard, put it here. Then put it outside of the main function. Quick fix, import time. Alrighty. Let me use my library util, parse JSON. First need to import our package and call parse JSON. Type, what's the type? Auto generated. Let's call this test JSON. I don't really want to, like, usually we want something, what is this, like, seems like a user, you know, a user JSON response. So I'm gonna say user and put user here, and we need the test JSON. Since it accepts byte, we need to read file. OS read file. You know what, let's just use one of my utils. Read text. Oh shit, this returns stringified data. Not cool, bro. So let's just return bytes instead. This is pretty useless, so let's just return data and error. So we got a read file utils read text pass test JSON returns data error, and then pass the data here. This returns user object and error. User is now we can use JSON Marshall indent user and like this. This is a pretty JSON. And print pretty JSON. Assignment mismatch, but JSON returns true. Error or something. What is it return? Byte and error. Right, now let's run it. Cool. We were able to print the JSON. So the JSON Marshall indent, it works on any Go object. It doesn't have to be, you know, you don't have to print JSON. You can print any Go object, I think. Pretty useful if you want to quickly see the JSON or debug or something. All right, with that, we are done with working with JSON. Okay, can we create a library function for this? Okay. Func. So Marshall indent returns it returns a byte. So what it needs just a type. So here let's put t any what do we call this? Let me just call it object t, object of type t. And then returns byte or error. JSON Marshall indent object this already returns bytes and shit, so we should be good. Let's use the pretty JSON user. So everything should work like before. Okay, let me ask ChatGPT if this is a good way to implement it. This is good. Any improvement? Tiny thing. Generics is unnecessary used, but JSON already accepts any, so this generic doesn't buy you anything. Your code is effectively same as object any, because you never use T for type safety or return T. Yeah, that's what most devs would write. If you want strings directly, super useful. Kind of right now, cleaner utility, string error, pretty JSON string. Less ceremony. If you want debug print helper, pretty JSON object and returns error, print a JSON. Very convenient for debugging, tiny customization, maybe hello indent choice. Use my tag for reusable, and probably keep simple and idiomatic. So me using generic is useless because I'm not returning the generic type, so this is useless. Might as well remove it. So this is pretty JSON. We can print pretty JSON string, pretty JSON string, takes object any and returns string or error or something. Okay, expected one expression. Marcel, what is this? Marcel indent. What is going on here, dude? Okay, pretty print JSON. Let's do that. Pretty print JSON string takes user, pretty JSON string returns text error, fmt print ln text. Undefined text. Quick fix, create variable text. Oops. Okay, pretty print JSON string. This uses string print JSON. Let's print JSON string. Same thing, but we print it. We don't return anything, but instead we print it. fmt print ln string data. So let's handle error. How do we handle the error? This returns error and return. Okay, this returns error. If error not nil, return error, return nil. Okay, cool. Now again we can print JSON string text user. Same thing, different functions. Now we can put this in our library. So these are like JSON related functions, helpers. Cool, that's pretty much it for today. So we checked out a JSON and we created some library functions. Great.